Okay, welcome to my shed at home. I'm going to talk to you guys about two kinds of switches. The first one I'm going to talk about is a Mercury switch, and the second one is a magnetic switch. A Mercury switch is a switch that comes from an old air conditioner. Luckily, actually it goes this way around. Luckily, I can do this at home and play with mercury because at school it's a banned substance. I'd get into trouble by bringing mercury to school. But what's really cool about a mercury switch, and you can actually see the mercury over here inside the vial, it's sealed. It's also called a mercury tilt switch, but what's really cool about it is as you move the lever, the mercury just falls from one direction to the other, and it either closes or opens the switch. And advantages of a mercury switch are that it's sealed, so it's not going to corrode, and you don't need a lot of force to move the switch. Just a little very simple slider will allow that mercury to flow, because mercury is a very dense metal. It's got a density of 14 compared to water, which is 1. So that's 14 grams per cubic centimeter. And because it's so dense, that's also a disadvantage for this type of switch. The disadvantage is that mercury, and you guys in physics know that inertia sometimes prevents objects from moving. And mercury, because it's so dense, its inertia causes it to sit in one position. So if you're going to, for instance, if you're going to tilt the mercury in one direction, for a brief moment in time, that mercury actually sits in position because it's got a lot of inertia, and then it flows. So a mercury switch is not as fast as a switch that is going to have an immediate contact. And the other disadvantage, obviously, is mercury has a high toxicity. So if this vial breaks, we'll have all sorts of problems when the mercury gets out. But really, if it just gets into your bloodstream, that's the main problem. Breathing it in is the main problem. The second experiment I'm going to show you guys. Okay, let's stop that for now and see. Okay, the second type of switch I'm going to talk to you about is called a magnetic switch. An example of a magnetic switch would be the circuit breaker. The circuit breaker I've got here in my shed. Come a bit closer. And a circuit breaker works when the magnetic field. Let's start that again. Don't do this at home because it's not safe. But I'm a professional, so I can do it. And let's just talk a little bit about the wires that we've got in there. We've got the standard white wire, which is the neutral. I can touch that one. We've got the black one, which is the live or the positive. I can touch that one too. And then we've got the green, which is the ground, or in South Africa we would call it the earth, same thing. And that one just carries any excess current harmlessly to ground. Now, at the moment, there's nothing between the live and the neutral wire, or the positive and negative wire. There's supposed to be an appliance between them. So this would be connected to a heater or some sort of motor or any electrical appliance that has got resistance in it. And resistance actually weakens the current. If I make a short circuit with these two wires, so if I touch this one and then I touch this one, I'm going to get shocked, and I'm going to be the resistor. But what I'm going to do is I'm going to touch them directly. And touching them directly is going to create a short circuit. A short circuit is an easier path for the current. That easier path results in a stronger current, and a stronger current is dangerous because it can cause fires. But that stronger current is going to flow through our circuit breaker over here. Okay, and the magnetic field generated in that circuit breaker is going to be strong enough to actually pull that switch, and it's not going to work. Again, don't try this at home, but I'm going to touch the live and the neutral together. And now I can't do it anymore because the circuit breaker is off. And so I would need to just reset it.